Okay, sorry I've been gone for like 3 weeks. Just been working on some projects and haven't really had the time to film a video, but we're back and we're heading into some for loops, I believe. Or I think it's actually conditionals first, and then we're gonna hit for loops. I don't remember where I left off, so we're just gonna have to use the power of editing to not waste. Anyway, let's record screen and we can get going. So let's see where we left off. Let's check the test set, eval test. So we got blocks, we got, oh yeah, some conditionals, Boolean expressions, and yeah, we did if statements. Let's run the test to make sure everything still passes, because I have not opened this code in a while. I do have some projects in the pipeline that I'm working on, and hopefully those will surface as videos very soon. Okay, so we have that going. I'm actually gonna pull out my little magic trackpad. Okay. Also, I'm not using an external keyboard. This is okay. Pause. We're gonna come back. So, I believe I want to implement logical operators, so and or. Did I pre-read this? No, I did not. So, we're gonna have to, I don't know, words aren't working right now. Okay. All right, let's see. So true and that should equal false. We're writing tests is what I'm trying to say. That should equal true. Let's say true. Actually, it's false and true. Should also equal false. So I think I'm just gonna do ands right now, and then after that I'm gonna do ors. So as you probably already know, ands only true if both sides are true. We're gonna run these tests, those should fail. Go ahead and implement that. Do I have ampersands in the scanner? Let's see. I don't believe so. So yeah, we're getting invalid character in the scanner. So I'm just gonna go ahead and place that here. So what we gotta do is we gotta say if peak equals another ampersand. We're gonna add a token of type and if it's just a single and, I think I'm just gonna throw an error because I don't feel like implementing what's it called, binary and. So we're gonna say we're gonna advance, otherwise throw error. I actually learned a new thing that in Swift 6 you can throw a specific error. So when we throw, oh, okay, yeah, so string has to also throw that error. But to do this, it means this can only throw a certain kind of error. So that's kind of helpful, in my opinion. What is it, not centered? All right, so, and then do that again for, oh, okay, that's just a stupid error that didn't get cleared. Okay, so now we're getting a different error. It's probably in the parser. Okay, so, all right, so it seems like we're able to scan. I should add a test to the scanner though for that. We're gonna just say and after that slash, we're gonna scanner routine open type equals and then this will be 15. I need to refactor this test so I don't have to manually count these things. Cool, we're failing. Oh, because I didn't update that. See, that's stupid how I did this. But anyway, we can fix that later. Okay, so scanner can scan and tokens. Scanner can scan and tokens. And then from here, we have to add a prefix parse or infix function. So infix and that should equal parse. Or can I just reuse parse infix? Probably can just, yeah, we're just gonna use parse infix. Let me write a test in the parser as well to make sure we're parsing these. So we can just do it in all the one of these binary tests. You did a binary test on me, it would come up non. Stupid. Alright, anyway, parse bind. So we're gonna say. So that should just be a binary. Left will be a boolean, value true. Right will be a boolean, a value false. Token will be a token of type and. Run that test. This should equal 8 now. Cool, we're passing. That means we're able to parse those, and then now we just have to evaluate. So we head over to the evaluator. Oh my god, this is a very long switch statement. Okay, so case dot and. So the right and left can only be booleans, I believe, as boolean. Oh, it should be as bool actually. Let right equal right as bool. And we're just gonna return left and right. I forgot let. Cool, that passes. Okay, so next we want to test ors. So we're gonna say boom. Gonna add another one. Gonna be the same thing basically. Scanner dot tokens dot token type equals or, which does not exist yet. This is gonna be 16 now, and the total count's gonna be 17. Run the test so it can fail. Okay, so I'm gonna add a token type. It'll be case or thick. Now we're gonna build and fail. We're gonna hit that scanner. So we're basically just gonna do the same thing here. Check for one. Those, I don't know what that character is called, but whatever that character is called, we're gonna check for one of them, and then we're gonna check for another one. We're gonna add the token of type or. We're gonna advance, and then else we're gonna throw an invalid character. Okay, that should pass now. Boom. Okay, now we're gonna do parser. So we're gonna say true. So it's gonna pretty much just be the same thing as this one. Comma there. And we're just gonna switch it to or. So it's gonna fail. I apologize for going so fast, but trying to create content and I'm very behind, so I'm talking fast. But not for any real reasons, just because I'm excited. Infigs. I really love the prat parser thing because it really does make me what? Oh, okay. Yeah, I forgot to change that to 9 because now we have 9. And now that passes. It's so easy to add another like binary expression. It's pretty sick. And now we just have to add more tests. So I'm gonna just copy and paste those, and everywhere we have an and, we're gonna do or instead. And then we're gonna adjust these. So true and false should equal true. False and true should equal true. And false and false will equal false. Okay, so we're gonna go ahead and do that. Gonna fail. To make it pass, we just have to go into the evaluator and do basically the same thing. So dot or. We only have to implement for Boolean. So left equal left as bool. You know what? I can put these in. So we're gonna say dot or, and then we're gonna say what is? Let's scroll up. Okay, op.token. So token type, I mean. So we're gonna say operator dot token type equals dot and. If it's and, we're gonna say left and right. If otherwise, I'm gonna say left. Okay, so if we run that, it should pass. Boom, we're done. Finished conditionals. All right, that was the easy part though. So I'm gonna take a break. I'll be right back. Okay, I think I forgot something. So we actually want to allow things that are, well, actually, so in the book, they actually allow things that are not Booleans if they evaluate to truthy. I can't remember if I implemented truthy. Yeah, bless. Oh yeah, I did. We actually want to say, yeah, how did I do this? Okay, so what does is truthy do? It evaluates the expression and sees if it's a bool. So, I think I do that earlier on, but okay. All I do is where am I using this? Let's actually think about that. So eval. Okay, if so, yeah. So these operands are expression. Yeah, I don't think I care about if it's so if we have like 1 or 0 on either side of an expression. Do I care? Not really. Oh, but I did forget something. We have the short circuit. I forgot about that. So so basically we want to say if the first side is actually, yeah, let's delete all this. So what short circuiting does is if the first part evaluates to something that will always make the expression true or false, then we don't want to evaluate the second part. So the way I implemented it will work in most cases, but not how people expect. So we actually want to do. So I'm gonna say we're gonna do a different function. So eval, because this could get a little longer. Left. Right. Okay, so we're gonna say eval conditional. Okay, so these have already been. Okay, so these have been evaluated already. Okay. I think because I'm doing it differently from the book, this shit is gonna be a little bit different. I don't know. I think. Okay, so I actually wanna to implement the short circuiting. So before we even evaluate these expressions, I'm gonna say if operator dot token type equals and or operator dot token type equals dot or, then we will call conditional, and we actually do want to pass an expression. So okay, so now we're here. We're actually gonna pass in the operator too. Can't type. So we're gonna check early whether this is has an and or an or, and from there we're gonna say switch on operator.token type. Case that is an and, we're gonna do one thing, case or, we're gonna do another thing, and if it's neither, we're just gonna throw a runtime error. Say valid operand. I don't think that's right, but I don't care right now. Okay, we're gonna say if it is an and, we're gonna say left. Right, if left, we're gonna switch this truthy to throw a runtime error. I'm not gonna go through all of these and change them on video, but just God, may have to change all of them. And it'll be converted to runtime error. Yeah. Okay, we're just gonna not do that right now because it's gonna take forever to change all those things. Okay, so we're just saying regular throws. Okay, so we're gonna say try if left is truthy, left is not truthy, we can just return false. And then then we're gonna say is truthy. Okay, so logic here is we check if the first side is truthy. If it's not, then we know that it doesn't matter what's on the right. The whole expression is gonna be false. And then since we know left is truthy, when we get down here, we just have to return whether right is truthy. And then for this one, we're gonna say the opposite. So left, if left is truthy, then we're gonna return true. And then we're just gonna say return right. I believe we're gonna return if right is not truthy. Let's see. Okay, so let's fails in this case. So I think, all right, cool. That works. All right, so we have short circuiting now. All right, did it right this time. All right, next is loop. How long have I been recording? I don't want the whole video just be conditionals because it's kind of boring. Let's do something cool since I've been gone for a while. All right, so loops. So we're just gonna, first of all, we're gonna scan while, which we do. We already have. Okay, while and for are already caught, so we just have to say, we just have to parse it. Write a test for parsing a while loop. So we're gonna say, what will a while loop look like? So while, wait, here. Did I write an example? The example code. I did not. I wrote for loops, but not while loops. Okay. Okay, so it's just gonna be while. While an expression, and then there's a block. So block is return infinity. Return infinity. Sure. Okay. So the expected expression should be I don't believe I have while loops in my syntax tree, so we're gonna have to add that. Struct while. Let while be an expression. I think it's statements in some languages, but in ours is gonna be an expression. And then we just need the condition is an expression and block, or let's call it body. And that will be a block. So, that's all we need. And then, so. All right, condition should be a Boolean value true. And the body should be a block with one statement. And it's just an expression statement with a return. Oh, have I implemented return? I have not implemented returns. Okay, so, all right, we can't put that there. Instead, we're just gonna say string. So, gonna be an expression. And the expression is just a string value. Okay. Yeah, and then we're gonna say like equal, or actually equal parse the input. I call this source first as file. No, it should be stupid. Expression same. And then the expression is dot expression. Then okay. Have that, and then we want to say expect expression condition equals expected dot condition, and I don't think that's gonna work. Okay. Oh yeah, so we're gonna say let condition equal condition as boolean value should equal expected condition. Okay, so that, and then we're just gonna do the same thing for the body. So, okay, so what I'm just doing is just grabbing the values out of those expressions, and then we're just gonna check the values, run the test, it fails. Okay, so there's gonna be a prefix function. So we're gonna say while, gonna create a new function, gonna call it parse while, put it, I'll just put it here. Parse while. Actually, I'll move it down lower by the other expressions. Yeah, let's put it after parse if. Okay, so how does a while work? So we hit the while, believe, yeah, we have to advance since we here, and then let condition equal try parse expression lowest precedence, and then from there we're gonna say it's gonna be similar to an if. So we're gonna say if, and then we're gonna try to consume a left brace, and then we're going to body equal try parse block, and then we're gonna try to consume a right, and then we're just gonna turn a while. Okay, let's add a what's it called, breakpoint, see why this is happening. So, let's see what the previous is. Okay, so we're saying, oh, I know what's going on. So the block already handles the right brace, so I actually don't have that there. Okay, so we're parsing it, and then to evaluate it, we just have to, again, write a test, a new test. Okay, for that, I'll be honest, I don't 100% know what's the best way to test a while loop. Let's see. Let's think about this. Because we don't have returns right now, it's a little bit of a pain. Okay. Yeah, I feel like I should definitely. I should probably. I'll do return next video. All right. Anyway, so let's see. Let's source. That should be. So obviously I can't test with an infinite loop again. So for this we actually need some kind of iterator. So let's say let I equal 0 while I is less than 2. And while that's happening, actually, yeah, let's do, and then we're gonna say j equals 0. So we're gonna say j equals, I don't need both of these. All right, so we're gonna say I equals I plus 1, and then we're gonna say I. So I believe this should evaluate to whatever I is. So at 2 should equal You know what, let's do 10, and then I will equal 9 at the end, I believe. But whatever, we can just see. So let's see, result equal, where's equal here? Result, source, and I'm just gonna print the result here for now, and then I'm gonna write a test after. My brain isn't working. All right, let's see. One thing about TDD that they don't tell you is that you don't always have to completely write the test first. You can write it after, it's not a big deal. In my opinion, it's better to write it first, but when you're in a situation where you don't know what test to write, it's good to just, write the code first and then test it after. So we're gonna say eval expression, so the case let while expression as while return try eval while passing that while expression. So we're gonna create another function. I already forgot what I called it. Okay, just eval while. Okay. All right, so it's just going to okay, so now that I'm thinking about it, while actually probably should just be a statement, because I don't really want while to return a value. So we're gonna change that to a statement, and that's gonna change my test. Okay, so, and we're gonna say, oh Lord, to replace everywhere that Russian. Need to delete that, and then parse while is going to be called a layer above. So we're gonna say if match while return try. Okay, cool. Let's see. Okay, so I don't need that extra advance now, because when match is being called, it calls advance. So I don't actually need this here. Okay, cool. We're parsing it correctly now. Okay, now that this is a statement, that'll make evaluating it a little bit easier. So let's run those evaluator tests, see them fail. And all we're doing is just basically doing a one-to-one with what it would be in Swift. So I'm gonna say while is truthy, condition. So we're gonna say while is truthy, we're just gonna eval each statement, or eval the block. Okay, these throw, we're gonna have to do that, not that. And then we just turn nil. Okay, yeah, this in the wrong place. Okay, let's just see what that prints out though. Or, whatever, man. We're just gonna say expect 9, I believe. It should be either. Should be either 9 or 10, I know. Okay, yeah, it's 10. Why am I stupid? I have a bachelor's degree in math, and I couldn't do that simple math. The reason I was confused is because I didn't know if it gets called after, like the adding when it's less than 10. Whatever, it doesn't matter. We got it, it works. Move on. Anyway, last thing I'm gonna do for this video is for loops. So for loops in the book, they actually don't really implement for loops. So to speak, they kind of just use while loops with what's called syntactic sugar. So really all we have to do is parse it. And then after we parse it, we just use the code we already have for loops. So first of all, I'm gonna parse it. I believe, I should maybe read the book, but I think it'll be fine. Famous last words. I always say that. I'm like, oh, it'll be easy. It'll be fine. And then it's not fine. So, so this, I think for now I'm actually just gonna implement regular for loops, not like the fancy ones that loop through an array, just because we don't have arrays. So it'd be kind of hard to do that. So we're gonna say for I equal 1, okay, let's just say, yeah, I equals 1, I less than 10, oh no, I equals 0, I plus 1, so we just want to say, okay, so we're just gonna go ahead and do similar stuff to the last time. So this is gonna be 4. Doesn't exist just yet. So, okay, so we need an initializer, which will be an expression, or actually, or it'll be a let. Yeah, it'll be a let statement. So, and then condition, that'll be an expression, and then part will be an increment, so, which also is an expression, and then we have the body would be a block. Okay, so we just have to parse that, nothing new, so we're gonna check for keyword. Okay, turn, try, 4. So parsing a for loop will be similar to parsing a while loop. And also because I changed while to a statement, I'm gonna move it to where the statements are. This is very arbitrary, to be honest. I'm not commenting, I'm not adding any documentation, it doesn't matter. No one's really looked at this code anyway, except for you people. So we're gonna say throws kind of 4. All right. So first thing should be let the initialize. We're gonna parse a let, then we're gonna that's gonna grow and check for a semicolon, then we're gonna say like condition equal try parse expression, and then we're gonna consume a semicolon, then we're gonna say the increment, which is also an expression, and try consume left brace, and then we're gonna have the body, and we're gonna try parse block, and then we're gonna return a 4. All right. Okay, so I'm actually gonna just change this to a statement because a let statement, previously we did not have it. Return a let statement. We had a return in it, just a generic statement. So, okay, oh, it's optional. I'm just gonna throw parser error. And I'm just gonna create an error. All right. Let's see how that builds. Okay. All right. So if we go to parser, we just have to do all this now. So instead of creating a whole ass statement, I'm just gonna unwrap everything from the for, and then I'm going to what am I gonna do? I'm gonna unwrap them and then check their values. Okay, so I'm gonna say increment. Okay, so where are we testing? Let's see if these crash. I haven't actually parsed it. Oh, okay, I did parse it, but it's not working. Alright, let's see. Flag. Okay, so add some breakpoints. Yeah. God, no. Let's do PO. Oh, okay. So I'm actually gonna do parse statement. Okay. So it didn't crash. Let's add some expectations here. But the fact it didn't crash means that the correct is parsing them to the correct types. Just some little expectations to make sure things look right. Condition, left. All this. You know what? I'm just gonna leave it here because this video is getting very long. I'm sure it's parsing correctly. When have I ever been wrong? Okay, let's move on to actually evaluating it, and then we're gonna stop doing this. Okay, so we go here. Oh, this should be called while statement. All right, so we find a for statement. Okay, so what do we do? Let's grab all the stuff and put them in vars. Why did I say that like that? Put the stuff in vars, and then we're gonna do stuff after that. So, all right, what are these things called? Initializer equals that's 4. And down initializer. Condition equals that. Increment. Okay, so we have them in variables. So we're gonna say I don't know what I'm doing. Let me write a test. Alright, so here's what we're gonna do. We're gonna say for I equals 0. Less than 10, I equals less than 1, and then say j equals a plus 1, and then just do j, and this should be the same. I forgot to put blank. It's gonna return anything right now, so that's cool. Fails as expected. Okay, so let's evaluate the initializer. Runtime error. Let's throw just a general error for now, and then we can say initializer. Okay, so now we have, after we do this, we can just say, we don't really care. Okay, So we have we have a divide variable now, and then from there, can we just say? I'm so confused. I think you just have to say, true the condition, or standing dot condition. Or standing dot body. Okay, so we don't need that. You don't need that. And then we just have to say now assign. Oh, I don't know if this will work. Okay. Don't care what the result is. Oh my God, it worked. Okay. All right. Well, damn. Okay, I should explain what I just did though. What I did is we evaluate the let statement after we check that it actually is a let statement, and then we just do a while loop for this condition. Each iteration, we evaluate the body, and then we check if the increment is an assign expression. We evaluate the assign, which will increment the condition, and we just keep going until it's done. Cool. That was for loops and while loops. This is a long video. I won't lie to you. I need to learn how to make shorter videos. That's next on the docket. Anyway, thank you for watching. Please like and subscribe. I will try to be back sooner because I know you missed me. Don't lie about it. Anyway, thank you for watching. Bye.